All right. Good morning, everybody. We made a little bit of a breakthrough again. Essentially, I figured out how to make it loop to the left and then come back to the right. Um, what I said before about how LSL and LSR isn't quite as simple as it seems, I was actually wrong. It is pretty simple. And I'm gonna make this video really quick because I did most of the explaining on the logical shift to the left in 2 videos ago. Um, just gonna show the code right here. This is from the previous one. It looks a little bit intimidating, but if you want a full explanation on how we got here, just look at the video before this one. Essentially, the only changes that I did was I copied the function of changing the logic to the left and I pasted it down here. So we have, and I also changed it so that it shifts the logic back to the right using LSR. Since we learned that LSL shifts the logic to the left one, LSR will shift the logic to the right. So as you see here, we have loop Y. Loop Y is going to be shifting the logic to the right by 1. And it's going to shift the logic from LED 1. And then it's going to load accumulator A with 255, with the value 255. And then it will go into loop U as an embedded loop, and it will do nothing. And then decrease the value of accumulator A by 1. And then it'll check to see if it's 0. And if it's 0, then it'll move on. And if it's not, then it'll loop again. And it'll do that until it's 0. And then it'll move on and load accumulator A with 255 more, 255 more. Let's say the value 255. And then it will go into loop I. This would be a second embedded loop, and it will do nothing, decrease by 1. And then it's the same thing as loop U, but it's just again to double the time. And then after it goes through that set of loops, then it'll go back into loop Y, and it'll decrease the value of um, accumulator B by 1. We have it to 5 because it's going through 1, 2, 3, 4, and 5. So it's going to go back 1, 2, 3, 4, and 5. It will decrease by 1, and then it will check to see if the value in accumulator B is 0. If not, then it'll repeat the loop until it is. And by doing that, what we are doing is this. Right now, go to the left 1, 2, 3, 4, 5 spaces, and then it'll come back 1, 2, 3, 4. So if I reset, you will see this logic repeated here. Perfect. And if you want to just fix it, then you'll just change the accumulator B to 5. And we could do this with 8 LEDs. Yeah, might as well. Might as well do it with 8 LEDs. Let's see. Boom, boom. And if we wanted to add a couple more, then we can just do this. Connect LED. This will be pin 7. Oh, wait, no, pin 6. And this will be pin 7. So now we have 8 LEDs. And we're going to set it up like this. It's going to go from here all the way to here. But before I do that, I need to set accumulator B to 5, 6, 7 to 7. And I need to set this accumulator B to 7. And this should have the logic shift all the way to the last LED. Let's try it. Let's reset. And then let's start. Okay, so the reason why I did that is because these are actually shifted. You see, this is 2 and this is 3. So it goes 1, 2, 3, 4, 5, 6, 7, 8. And if I just drag it like this, um, actually, yeah, I need to bring it up like this. It'll look all normal if I do it like this. And let me just change it to 254. It doesn't really matter, but just to change something. And then we want to reset. Yes, continue, and then start. And there you see we have the first loop. If we wanted to have it do it more than once, what we can do is just have a bigger loop on the outside, and it would decrease by 1. I wonder if there's an accumulator C. I don't think there's an accumulator C. If there's only an accumulator A, then we'll just have to like set. We'll have to clear the value and then set it, and that's doable. But for now, this just shows that we can bring the logic all the way to the left and then bring it back to the right. So now I'm going to pour all my focus into sectioning your code, as in like having I forgot what it was called, but what was mentioned earlier, how you don't need to actually write all the code. You can actually have a calling code. I'm gonna figure how to do that, and I'll make a video on it. But we are almost done with this project. The last part of this project will be to let me just sign in. Okay, here we go. The last part of this project will be to use the CPX function in order to stop the left shift when reaching the uh, most significant bit, which will be the eighth bit. So it'll go, because if you leave it alone, if you just keep on having the code continue, see it goes on forever. What I think the CPX function will do is that once it reaches the most significant bit, it will stop it, and then it'll go down to the least significant bit and then stop it again. I'm not 100% sure, but I need to do a little bit more research into what CPX is or CP is, because X is just the variable. So we'll just look into CP and I'll make a video on that. So essentially, what we've learned how to do, we've learned how to light up an LED, have it blink in a sequence, go all the way to the left, the most significant bit, and then come back to the right. Um, and we're almost done, but that's a good amount of progress for this video. So thank you.